Hello everyone, thank you for coming. My name is Manuel Bernhard, and I'm here today. I would like to talk about a project of moving from PHP to the Play framework in a short period of time. So what I wanted to talk about today is first give you a bit of background. Why was this project necessary and why this technology choice? Then I'd like to explain what the technology is, the platform we used, how we built this new platform, what choices we had to do along the way. There was one important part of the project which was about migrating the data, and that was quite challenging. So I will dive into that a bit. I will quickly go over operations and give you a summary and an outlook on the future. A few words about myself. I'm a freelance software engineer. I'm based in Vienna in Austria. I've been working on the web with the web for most of my professional career, building web applications from the backend to the front end. For the 4 past years, I'm working mostly with Scala and Akka and the Play framework. When I have some time, I'm also co-organizing the Scala user group in Vienna, and I also try to help an open source project. So, the background. So this really is the story of the new platform of Talenthouse. Talenthouse is a company, a startup located in Los Angeles. It has offices in London and also soon in Munich. And Talenthouse is about connecting brands and artists. We'll see how it does so in just a minute. The interesting thing here on a technical perspective is that it's got many users and that these users come in bursts. So you will have bursts of users suddenly coming in, and it makes for a very interesting technical challenge on how to deal with these users. So this is what you see when you go on the website, talenthouse.com, and you haven't registered yet. You may not see exactly the same picture in the back end here. It's art that's provided by one of the artists in the community. And when you log in, what you see is a set of so-called creative invites. So these invites here, I've been searching for Spotify, are sort of campaigns in which a brand will say, "Hi, hello, we're Adidas, and we need your help for designing new sunglasses." Or, "Hello, we're Spotify, and we need your help for creating a music video about music." So this is what you then see when you go onto the invite itself. You get a description of what it is that the brand needs your help with, or how it is being ranked and rated, and what you can win. You then get the chance to submit your work, and you can submit different formats. This can be video, audio, other kind of types, various types. You can go through them. And at the end, there is voting. Voting happens over Facebook or Twitter, and soon also over the platform itself. And you have different kind of winners. So why was it that there was a need to rebuild the platform? Well, in December last year, Daniel, the CTO of Talenthouse, came to talk to me and said, "We have this site, it's slow, and it's being developed by an external company. The whole thing is developed by an external company. They're not in the same time zone. Communication is difficult. And it seems like it's hard to evolve. And really, we want to build something with lots of great new ideas, what we want to do, but we feel that the underlying technology is not going to cut it. So what we want to do is to move to cool technologies. We want to use Scala, the Play framework, Angularjs, Elasticsearch, etc. So this sounds really cool, quite exciting, really, when you hear about it. And then he told me something even more interesting, is that, maybe we won't have access to the source code. We have access to the database, but there's not only one database, there's more of them. And we only have 3 months of time to do this. So, when you're reasonable and adult and grown up, what you do in such a situation, you say, I'm sorry, but 3 months, you can't do that. I won't recommend it. But then the inner geek goes like, yes, of course I want to do that. And it's been a fun ride. I'm really glad I took part in it. Let's talk about how we've done all of this, what choices we've made in terms of technologies, etc. So at the core, the idea was to use the Play framework along with a set of other technologies. And the Play framework, what's nice about it is that it's not really opinionated as to what other technologies you use it with. It doesn't tell you, you have to use this backend library to connect to your database. You have to use this JavaScript library. It's jQuery only and nothing else. It lets you do these choices yourself. That's quite nice and considerate, especially if you're in a hurry and you know what you want to use and you have a few things that you like that you want to use. So the Play framework, who has heard of the Play framework here before? Yes, many, okay. But the Play framework really, Play, Play, it's like, it's this toy that you can work with, but play with, but not really use in production maybe. That may be something that the name may convey. I can assure you it's not the case. Play really is a best-of-breed MVC framework, model view controller. It's been inspired by Ruby on Rails, Django, Symfony, and others. And it was developed the first release came out in 2007, so that's already 7 years old now. And it was developed by a company in Paris that was called back then Zenith. And they looked around in the Java space, and there was nothing quite all these fun other tools that were available in other platforms. So they took all of these learnings in, and really, if you were to ask me, I think there's two things that are unique to Play. The first is that it's trying, or no, it's not trying actually, it's absolutely obsessive as to compiling all of your code. So not only your business logics, not only your style sheets, it will go and grab everything it knows about. It will grab less, it will grab JavaScript, it will grab CoffeeScript, TypeScript, whatever script it knows about, it will try to compile. And so, while you're developing and you refresh the browser, if one of the things it tried to compile has an error, it will prompt you the error and the line right during your development process. So instead of finding errors later on, while you're testing, all things, including templates, are compiled, and that saves you some time because you don't have this context switch, like, what was I doing just now? You're diving right in. The other thing about Play is that it's designed to be horizontally scalable and reactive. So you may have heard the word reactive before. Let's look quickly into this reactive concept. There is a website called the Reactive Manifesto in which the reactive concept is detailed. It's actually quite old. There's a paper from '85 where this term was first presented. And in one way, the idea of reactive systems is that users these days, when you go, for example, onto Facebook or Twitter or LinkedIn, you want two things. You want the site to load instantly. You're not going to sit there while it's loading. You will zap away, probably. And you want it to be available. You don't want the last time you've seen a 500 internal error page on Facebook is probably a very long time ago. These are things that users these days take as granted. So how do we achieve this? There's two things that we need. First one is we want to be able to react to load, to be scalable. So when suddenly we have, I don't know, an article somewhere in The Guardian linking to our site or on Hacker News or anything like that, and we have a mass of users that rushes onto our site, we want to be able to scale out. And once this rush is over, we also want to be able to scale back, because otherwise we're going to have a very expensive bill at the end of the day if we keep on running all of this service. Then, on the other side of this, we want to be resilient to failure. So it's not because a third-party site or API that you're using crashes or is not available any longer, or it's not because one of your backend system fails that your whole site has to fail catastrophically. It may just blind out. I don't know if you saw the LinkedIn front page, but there's many widgets there. And sometimes some of the widgets are not there anymore, but nobody notices. And that's just because one service may have not been able to respond at that time. But it doesn't matter because in its entirety, your application has been responsive. And then there is this paradigm called event-driven programming, where you will react to stimuli, where instead of sitting there and waiting and allocating resources for nothing, you just you just react to whatever comes in. And this event-driven architecture, this event-driven idea is quite interesting in regards to scalability, because what it also means, or should mean, is that it doesn't matter on which CPU core or on which server or node your event is being handled, as long as it's handled. So this input can be user input, requests, or failure notifications, or anything or the like, but you just handle it, it comes in the pipe, and you deal with it. So quickly, if you imagine these are your play instances here, and you have a very simple thing with a database in the backend and the load balancer there, it's very naive here. This is where you do the scaling. This is like what you see in Heroku. You scale this up and down, and new nodes pop up or pop out of existence, and it doesn't really matter for the user. It's completely transparent at this level. Okay, now back to Talenthouse and to how we built the platform. The first question we had to answer is, how do we want to talk to the database? We used Postgres in the backend. And the thing in the Scala world is that there is not only one thing, one database access drivers, there's many. So I wrote a blog post a few months ago where I tried to get an idea of surveying the space and seeing what kind of things were out there, comparing them to each other. And one of the reactions I got from many of the commands is, oh, have you heard about this library? Or I wrote my own library. So there is no real consensus yet, and there's more approaches emerging. By default, Play will come with anorm. Anorm is a library that was there from the beginning with Play, and the thing that we found is that it's too verbose. It's gotten a bit better with Play 2.3 now, but it still is. It still didn't feel like it would last very long. There is Slick. Slick is this library that's developed by TypeSafe, the company that's also backing Scala and Play and Akka. And the interesting thing about Slick is that it provides two ways of querying your data. The first one is that you can use plain SQL. And the second one is a type-safe DSL, domain-specific language, that's based on the Scala collections library. So this is an example. If you're familiar with Scala, you don't need to hear, but if you're familiar with it, I think this thing has a laser pointer, but I'm not sure. Yes, it does. So this part here is a for comprehension. And here you see that it's using methods such as sort by, drop, take, etc. These are standard methods in the Scala collections library. So it feels like you're working with collections in Scala instead of working with the data itself. Now, the interesting bit about this is that up until the very last point here, the list here, you're not actually running the query. The query is there. It's an object that you can compose with other queries. And one of the consequences of that is that you are able to if you have queries that look very much alike but are not exactly the same, you're able to avoid code repetition. And I find that quite interesting in some cases, because if you were to write plain SQL, you would just copy-paste things and then adapt them a bit, and with all the things that entails. Now, sometimes you really want to write SQL, and then writing this in the DSL might not be the most easy thing to do, or you just know SQL well, and then you just want to be entirely in control of how your database is being queried, especially when you have many users hitting it at the same time. And then Slick lets you use plain SQL, and you can map back to the domain classes that you were using otherwise as well. All right. let's move on to front-end and user interfaces. By the way, if you have any questions, don't hesitate to interrupt me. So for the front-end part, we used, in the administrative part of the site, we used Angularjs. Angularjs lets you do more complex things. And so this is, for example, the tool that's used for editing these campaigns. And the interesting thing here that AngularJS provides is two-way binding. So you can program in complex interfaces rather easily. And all these things, you know, you can drag and drop them. I can't really show it here, but you can swap things, drag and drop, add different types of bits and pieces. And all of this is very rich. Now, there is one thing about AngularJS, which I find, is that it's got the learning curve is a bit like a roller coaster. One day you will be very quick and fast, and you feel like you ride on you know, you're really in a good state. And then the next day you may be stuck for 4 hours with this little bug, and you can't find a solution or an approach to it. And one of the reasons I found is that the documentation still lacks a bit, the official documentation. There's many tutorials out there, but as soon as you want to dive deep and write your own integrations, etc., you need to be prepared to spend a bit more time on it. That's my take on it. There is another library we've used that's called React.js, and this one is provided by Facebook, has been open sourced recently. And the interesting thing about ReactJS is that it makes use of a virtual DOM. So instead of modifying the DOM in your browser, which costs, which is CPU intensive, which if you do many changes at once, can be slow, it does the change in memory and then only applies the diff of the changes to your DOM. And that way it's pretty quick. Also, unlike AngularJS, which is really a full-blown client-side MVC framework, ReactJS can be integrated quite easily in an existing page. And so you don't have to adopt the ReactJS way. In AngularJS, everything becomes this one-page, single-page HTML kind of construct where everything ends up in AngularJS. This one, you can just put it somewhere where you want to use it, and that's it. All right, moving on, we have used another few technologies from the JavaScript space to take care of assets. Assets such as, well, JavaScript, style sheets with less, etc. So one word about this is that Play, when we started, didn't really have an assets pipeline. Now with Play 2.3, there's a new module, or a new plugin called SBTWeb, which integrates some of that functionality and which goes it actually wraps Node.js behind the scenes, or a JVM version of Node.js. And so it can make use of all of these tools that exist in the JavaScript space. But back then we didn't have it just wasn't there. And so we built our own pipeline. So these tools are called Gulp.js and Bower. I mean, the ones we used. We use it for less compilation, JS minification, uploading assets to CloudFront, taking care of translation, etc., etc. It can do quite some things. There's many plugins predefined there, and that saves you quite some time when you want to do these things. Okay, so this was for the first part. I want to dive now into data migration, which was an interesting topic. But in order to do so, I need to give you some background about the source system from which we have migrated. And I never got really access to that source system. I only got access to the databases. I'm not 100% sure if this is what really was the case. It's my interpretation, but it's more to give you an idea what we had to cope with. So at the beginning was the Zend framework and Amazon SimpleDB. Amazon SimpleDB is a NoSQL database provided by Amazon. And So as said, users can submit things from different cloud services, but also upload their own MP3 files or video files. All of the metadata was captured in SimpleDB. All of this was being hosted on Amazon Web Services, and quite soon, the external company developing the site had to use Redis as a cache, because when many users were pouring in, this whole thing wouldn't work so well anymore. And then this happened. I think they started realizing that the data was more of relational nature, and they started building some things up in MySQL. And I think the intent was to move entirely everything over, do a clean switch, and go to MySQL. What do you think happened? This happened, cron happened. So now data was in two places, which during migration was interesting because you had things like user IDs changing. That's not cool when you try to migrate the thing. And now it gets weird. So there were files stored on S3, which had a JSON extension, but really would not contain any JSON data. They were containing JavaScript code. And some of the JavaScript code would evaluate to data. However, none of this was visible once you loaded the page. It was embedded entirely in the page, which leads me to think they used some technology on the backend server, such as Node.js, in order to get that. But I'm not sure of this, so I'm calling this a pirate Node.js server here. And if this is familiar to you, you may have seen this. It makes it hard if you want to migrate the data. It's a creative architecture, that's for sure, but it makes it hard to make any sense of how the data is kept and where to take it from. So moving on, another challenge here was the schedule of the data migration. Because we couldn't just take the site down, wait for a week while the data was migrating, and then put it up again. This had to be fast. So the schedule was more of a weekend and, 1 weekend at most. So the data migration was more of a day. And there were millions of users and a lot of items. And to make it worse, we had to actually go talk to YouTube, SoundCloud, and friends in order to make sure that the artifacts were still there, because there was a lot of stale data in the system. This is what we call a Big Bang approach, and that's, most Big Bang approaches, they bang. So how did we actually go about and migrate this? Whoop, there we go. We used Akka. Akka is a tool for building concurrent systems. We used it both from user migration and for the item migration. And Akka makes use of a few paradigms, and one of them is the actor model. An actor is a little piece of software that's it's cheap to have in memory. You can have millions in one JVM, and it communicates with others and reacts to messages sent to other actors. So an interesting thing, before I go on and go into how we used it, which scenarios we had, is we had to talk to all of SoundCloud, YouTube, etc. And in order to do so, we used Play's WS library, which is a REST client. And this one makes use of Scala futures. And Akka also knows how to work with Scala futures using the concept, they call it piping. And so these things integrate pretty well. In the case of user migration, this was pretty easy. You have one actor on top here that's just going over the legacy database, querying out the users. The Amazon SimpleDB doesn't have, well, it has paging in a quite elaborate way, so you have to sort of page over it and take some time to do all of this. And then for each user, we would send it off to one worker. There were like 100 or 150 worker actors flying around. And then this worker takes care of creating a new entry in the new database, going to fetch the profile image and all related information in various places. For the item migration, it was a bit more elaborate. The item migrator would walk over the migrated users. For each user, not at the same time, but it would fire up, I think, 50 or so, or more. I don't remember the figures exactly, but it would fire up other actors of the kind user item migrator. And these guys were, in turn, walking over the items in the legacy system and sending them off to a pool of item migration workers. And these item migration workers were talking to other more specialized actors in order to do stuff based on what type of data it was, and whether you had to talk to SoundCloud. If you were talking to SoundCloud and you were asking it too many things at the same time, it would start returning 500 internal server errors, messages, etc. One thing we don't see very well here, but there is a supervision taking on. So when some of these things would fail, they would, the parent actor would notice that, be able to recreate and resume. All kind of failures, would it be network or anything, are propagated back on the chain here. And that way we were sure that we weren't missing out on anything. You could stop this and start again. It would know where to continue. So a few weeks before the Big Bang, we started testing this, and this is what happened. We actually shut down the system, and this was just a test instance, a small EC2 instance, and it was running well enough to take down the whole site, which I don't know if it tells you more about whether this technology is great or whether the old site is not so great. I don't know, but yeah. So we eventually had to scale down what the system could do. Yeah. So a few words about operations. Yes?
Where did you run the system? Was it in an Akka cluster or in the same machine?
Well, we tested. We started with a single machine, Elastic Cloud, EC2. And then, we saw it doesn't make sense to take a cluster here because, yeah.
You mentioned the user IDs kept changing. So you had some kind of listening mechanism for changes that would feed in?
No, so what happened, they didn't systematically kept changing, but some of them did. And after a while, I sort of thought, okay, this is the double database synchronization thing going on. So what I had something that would run over the legacy system and over the new system, compare the amount of items, and then deduct what went wrong, so I could purge the broken users from the new system. So I had a lot of little repair workflows going on.
And how would you migrate the user item that was added after that user was migrated?
Well, the user item migration would always walk over all the items. The items of the IDs of the items were not changing, luckily. But so I could make a sort of three-way diff of what was added, what was removed, and what we may have to update. So we were always updating by default some of the metadata. So it was a simple synchronization mechanism there. Yeah. Okay. So for operations, since we were pretty much in a hurry, we chose to host everything on Heroku, and Talenthouse still runs on Heroku. Heroku is a platform as a service provider. It knows about Play. It integrates really well with it. And so deploying means that you package up a slug and send it off to Heroku. And then Heroku takes care of spinning up new nodes as a response to the new version coming up. There is one mode that we're using, which is a kind of a hot redeploy mode, in which it takes up in the new slug, starts up new instances of the new application while having still the old nodes on, and then switches its front-end routers to the new nodes and then shuts down the old ones. And that way, the migration is entirely transparent to the users. They don't notice anything. All of this deployment and building is done using Jenkins, which is a continuous integration tool. So Jenkins will run the tests, compile the slug, take care of a few other things regarding assets, and send this off to Heroku. And then for monitoring, for the logs, we use Papertrail. It's a tool really that aggregates many log sources, and you can search them in real time. And you can search for strings like error, and then you see where something went wrong. So it's quite convenient. Also, it makes use of we use New Relic to get statistics on response times, etc., which integrates really out of the box with Heroku. So this is how the dashboard would look like. You can see we have web workers and different kind of nodes. We started introducing a new kind of node, which are taking care of asynchronous tasks here. And you can slide these things up and down, except for the middle one, which we only want to have one of them. It's a node that will tell others that they need to do something now, or that take care of doing work that should only happen once. So we don't want more instances of that. Okay. So an outlook on the future, or a summary before that. So one learning from here is the Play framework doesn't get in your way. So, and when you're in a hurry, that's cool, because many frameworks frame your work, and they're very specific about how they frame your work. And this is something that the Play framework, since ever I worked with it, has been very consistent about, is that you do not need to adopt a certain kind of technology. You can really easily write plugins, integrate other tools, and there's many integrations out there, and if there is none, writing your own is really easy. We have a few plans for the future, which are quite interesting: live activity feeds, similarity search, etc. Talenthouse is hiring, shameless plug here. So if you're interested by what you just saw, if you think that this is something you would like to work on or work with, come talk to us after this call. Daniel is here. Yes, I think that's pretty much what I had to tell today. I'm sorry this was so short, but the schedule changed and I suddenly got 20 minutes more. So if you have any questions, please, I would appreciate that. Yes?
Did you use the Play views, or did you only provide RESTful services and totally develop the GUI with Angularjs, HTML?
So did we use the Play views, the Play template system? Yes, we have used the template system for all the public-facing things. So all the templates, so Play comes with this template system that uses Scala behind the hood. So it uses Scala syntax interleaved with HTML. There is IDE support now for it. And it actually saved us quite some time, because when you make, you write front-end code, etc., you easily make mistakes. But these things are compiled, so we'll notice these right away. It will notice when you forget to close something. And that was quite useful. And then for the admin part, we used Angularjs. The whole admin part is one Scala template, one HTML page, and the rest is Angularjs. Okay. Thank you very much.